Hello friends, welcome back. Here we go with the next set of deep learning interview questions that are pretty important for somebody to understand and to crack the deep learning interviews. It's pretty easy and I'm going to make it very simple. Let's go ahead with the questions. What is an autoencoder significantly used for? Let's first understand what exactly is an autoencoder. An autoencoder is a simple, in fact, relatively very simple ML algorithm which acquires the input image and reconstruction will happen. It reconstructs the input image and it is going to be compressed. The input image is compressed and this is also called as dimensionality reduction. We are dimensionally reducing the image. Well, this dimensionality reduction is very useful in the data pre-processing stage where we reduce and compress the image size, and this process of dimensionality reduction reduces the dimensionality of the considered data set and it's very useful. It is a process where you encode it and then decode it. We go with the compressed representation which is further decoded and you get the reconstructed input out through this process. That's what autoencoder is all about. Well, I hope you understood what exactly is an autoencoder and why is it important. Right. Can you list the three major layers in an autoencoder? It's input layer, hidden layer, and output layer. The input layer is also referred as the encoding layer. The hidden layer can also be called as the bottleneck or code layer. And finally, the decoding layer can also be referred as the output layer. What are the three properties or features one should remember with autoencoders? The first one is the data specific behavior. It's very specific to the data and this behavior is very important to be tracked. The lossy compression nature and unsupervised nature. All these three things are very important when it comes to the autoencoders. The next one is what is a latent feature? Well, these are the explanatory features extracted from the input image. Remember, these are the true explanatory features or factors that are extracted from the input image. If you see this image, smile 82, skin tone, hair color, glasses, bird, gender, all these are the explanatory features which are extracted completely out from the input image, and that's called the latent features. Well, distinguish between the observed variables and the latent variables. This is a very important term. Please understand. This is given through a very simple example here. You can see that here, the guys who are sitting here are the prisoners who only sees the images which are the shadow of the original content here. They never get to see anything else, and these are called the observed features and these are called the latent features. They are the shadow of something which is being shown from here, and this original content that we have here are real, and these are called the shadow images which are called observed one. The real variables are hidden. This is all hidden and they are not visible for these guys, and these real variables are the true latent variables. They are the true ones, but observed variables are casted by the real variables which are hidden. You can see that these prisoners are getting to see only the observed content which is nothing but a shadow of the original content. This is the major difference between the observed variables and the latent variables. Can you explain the relationship between the dimensionality of latent space and reconstructed image in an autoencoder? Well, this question is very important. Please recollect the question once more. Can you explain the relationship between the dimensionality of latent space and the reconstructed image in an autoencoder? The dimensionality of latent space representation is highly and directly related to the quality of the reconstructed image. It completely depends on the quality of the reconstructed image. Lower dimensionality of the reconstructed image will enforce a larger training bottleneck because of poor quality of the reconstruction process. Remember, if you have a lower dimensionality of the reconstruction image, you will have to go with the larger training bottleneck. It has got a poor reconstruction, poor quality in the reconstruction, hence it happens that way. Well, what determines the difference between the original image to the reconstructed image in an autoencoder? The loss function is the one that we need to remember here. The loss function helps to understand the difference in terms of loss from the original to the reconstructed one, and mean squared error is used as the loss function here, and I have represented it through a simple expression and you could see that in front of you. List the different types of autoencoders. We've got multiple types of autoencoders that I've already explained in my deep learning playlist. Denoising autoencoder, vanilla autoencoder, deep autoencoder, sparse autoencoder, undercomplete autoencoder, stacked variational autoencoders, and convolutional autoencoder. All of them are very specific and all of them are very in terms of functionality, they have their own features, and I expect you to probably go through it once more to understand things better. How does a denoising encoder work? It's very simple. Denoising autoencoder will produce a noised copy of the input through introduction of some noise. It's a corrupted content. So what I do is, I've got the original input, I add some random noise to it, and I get the noisy content out of it. So what happens? We are purposefully corrupting the input content by adding some noise. The noise is added to corrupt the input, and this is how it works. Now finally, how does a variational encoder work? Variational encoder works by parameterizing the latent vector z with mean vector and standard deviation vector. Remember, this is something that we need to be very careful about, and when you explain these terms, make sure that you understand things in a nice way so that you can explain it nicely. Now you see that I have got the mean vector. You can see that I got the mean vector and I have got the standard deviation vector. So VAE, which is nothing but the variational autoencoder, it works by parameterizing the latent vector z. I've got the latent vector z with the mean vector and the standard deviation vector, which describes the probability distribution, and this is very important for us to understand. The encoder will compute the latent variable z for the given input x, whereas the decoder will compute y for the given latent variable z. Remember it, the encoder will compute z, the encoder will compute z, at the same time the decoder computes y for the given latent variable z. So we have represented it in a very simple way here. I have got x as the input, y as the output. I have got the encoder playing the role here and it generates c, and the decoder generating the final output. The decoder uses the reverse inference from the latent space z to compute y. Remember it, decoder uses the reverse inference. This is how you can explain variational autoencoder in a very simple manner. More to follow, and I'll see you in the next session with more set of questions. If you like the channel and the content, please subscribe and give a thumbs up. In case you have any questions or suggestions, please go ahead and type it in the comment section. Thank you very much.